the universe keeps on expanding, increasingly more. In 1929, it was found out by scientists that the elements making up our bodies came from the cores of stars. By 1957, it had become clear that the sky is not just a beauty to see, but also reflects the huge power of the universe. There is so much going on inside the cosmos that we often have no idea what goes on. We question our life, the reason for planets and stars, and the opportunities of exchanged destinies. Often, we best pay attention to problems when they reach an important level, even supposing they're bound to impact us subsequently. Let me know what you observed inside the remark box. If you enjoyed the video, don't forget to like and subscribe. The universe, vast and mysterious, continues to expand, revealing countless phenomena that challenge our understanding of existence. Since 1929, scientists have uncovered a profound connection between our cells and the cosmos, learning that the very elements composing our bodies were forged in the fiery cores of ancient stars. By 1957, it became evident that the night sky, while breathtakingly beautiful, is also a testament to the immense power and complexity of the universe. Amidst this cosmic grandeur, humanity often finds itself questioning its purpose and the mysteries of planets, stars, and destinies that exist in the celestial expanse. Despite these wonders, we often remain indifferent to the universe's unfolding drama until extraordinary events demand our attention. Such is the case with Betelgeuse, one of the largest and most enigmatic stars in the sky. Recently, this colossal red supergiant has exhibited signs of alarming instability, drawing the intense scrutiny of scientists and stargazers alike. Betelgeuse, located more than 640 light-years away from Earth, is a star of staggering proportions that dwarfs our Sun in size. Its colossal nature and striking red hue make it a remarkable celestial object, captivating observers for generations. Even at the speed of light, it would take over 640 years to reach Betelgeuse, a journey far beyond the capabilities of current technology. To put this into perspective, traveling at conventional speeds would take over 12 million years, a duration that surpasses the entirety of human history. This staggering scale underscores the immensity of Betelgeuse, which has recently been observed trembling and pulsating intensely, raising questions about its stability. Stars, while appearing calm and steadfast from Earth's vantage point, are anything but tranquil. Betelgeuse, long classified as a pulsating red supergiant, is a dynamic star whose brightness varies in cycles ranging from 10 to over 2,000 days. These variations reflect its rhythmic expansions and contractions, processes that are visible manifestations of its internal evolution. Its brightness can fluctuate dramatically, ranging from magnitude 5 to magnitude 0, creating a stark contrast with other stars. Significant deviations in its luminosity have been recorded, such as in February 2021, when its brightness reached one of its lowest levels in years. These fluctuations are influenced by its surface temperature, which at approximately 3,500 Kelvin is much cooler than the Sun's 5,500 Kelvin. Despite its enormous size, this lower temperature means Betelgeuse emits less energy per unit area, making it appear dimmer than expected. Recently, its instability has sparked significant concern among astronomers. As a red supergiant nearing the end of its life cycle, Betelgeuse is experiencing dramatic changes in its internal and external structure. The star is gradually exhausting its hydrogen fuel, a process with profound implications for its future. As hydrogen fusion slows in its core, the outer layers expand, causing the star to grow even larger. Simultaneously, helium accumulates around the core, triggering a secondary fusion process known as helium envelope burning. In this phase, helium atoms fuse to create heavier elements like carbon and oxygen, releasing bursts of energy that counteract the gravitational forces trying to collapse the star. However, unlike hydrogen fusion, helium burning is less stable, leading to irregular energy releases that destabilize the star's structure. These irregularities result in pulsations that alter Betelgeuse's brightness and generate powerful stellar winds, which expel significant amounts of mass from its outer layers. These stellar winds reshape the star's structure, affecting its evolution and contributing to its dynamic nature. The rhythmic expansion and contraction of its outer layers, akin to a cosmic heartbeat, further highlight the star's instability. To study these phenomena, scientists use advanced tools like photometry and spectroscopy. Photometry measures variations in the star's light over time, offering insights into its pulsations, while spectroscopy analyzes the light at different wavelengths, revealing details about its temperature and motion. Together, these methods create a comprehensive picture of Betelgeuse's behavior, shedding light on the processes driving its changes. Astrophysicists have also used powerful computer simulations to model the star's internal dynamics. These models incorporate equations governing nuclear fusion, convection, and fluid motion to predict how Betelgeuse will evolve. One ongoing process within the star is stellar convection, where energy generated in the core rises toward the surface. This movement creates convection currents that transport energy outward, balancing the star's internal processes with its external luminosity. These currents also cause variations in brightness, manifesting as the pulsations observed from Earth. The interplay between gravity and radiation pressure is one of the most fascinating and critical factors influencing Betelgeuse's behavior, highlighting the delicate equilibrium at the heart of stellar dynamics. Gravity, the force that pulls matter inward, acts as a constant pressure attempting to collapse the star under its immense mass. Opposing this inward pull is the radiation pressure generated by nuclear fusion occurring within the star's core. Fusion reactions release tremendous amounts of energy, producing outward pressure that counters the force of gravity. This continuous push and pull relationship between gravity and radiation pressure defines the structure and behavior of stars, particularly massive ones like Betelgeuse. In the case of Betelgeuse, a red supergiant nearing the end of its life cycle, this balance has become increasingly unstable. As the star depletes its core hydrogen fuel, the nuclear fusion processes that sustain it undergo significant changes. When hydrogen fusion slows in the core, radiation pressure decreases, causing the gravitational pull to momentarily gain the upper hand. This results in the contraction of the star's outer layers. However, the contraction leads to an increase in core temperature and pressure, reigniting fusion processes, particularly involving heavier elements like helium. This resurgence of fusion generates bursts of energy that temporarily counteract gravity, leading to the expansion of the star's outer layers. These periodic expansions and contractions create dramatic fluctuations in Betelgeuse's luminosity, a phenomenon characteristic of variable stars. During the expansion phase, the star's surface cools, reducing its brightness and giving it a dimmer appearance when observed from Earth. In contrast, during the contraction phase, the surface heats up, increasing the star's brightness and making it appear more luminous. These cyclical changes in temperature and luminosity are not only visually striking, but also provide a wealth of information about the internal processes governing Betelgeuse and other massive stars. Betelgeuse's variability is particularly pronounced due to its immense size and advanced stage of evolution. As a red supergiant, it has already exhausted the stable hydrogen-burning phase that defines the lives of smaller, less massive stars. Its core is now dominated by helium, with fusion occurring in surrounding shells of hydrogen and eventually heavier elements. The fusion of helium into heavier elements such as carbon and oxygen releases less energy than hydrogen fusion, making radiation pressure more erratic and less effective at countering gravity. This instability contributes to the pronounced pulsations observed in Betelgeuse as the balance between gravity and radiation pressure becomes increasingly fragile. As Betelgeuse approaches the final stages of its life, its pulsations and convective activity grow increasingly intense. The depletion of its nuclear fuel sets the stage for a dramatic supernova explosion, marking the end of its existence as a red supergiant. Until then, the star's dynamic behavior continues to captivate astronomers, offering a rare glimpse into the life cycle of a massive star. The ongoing study of Betelgeuse deepens our understanding of stellar evolution and highlights the interconnectedness of cosmic processes shaping the universe. Through the dedicated efforts of scientists and the use of cutting-edge technology, we continue to unravel the mysteries of this remarkable star, reminding us of the awe-inspiring complexity of the cosmos. Betelgeuse's status as a red supergiant places it in a rare and fascinating category of stars that exist only for a short period in cosmic time. Unlike smaller stars like our Sun, which can remain stable for billions of years, massive stars like Betelgeuse burn through their nuclear fuel much more quickly. With a mass estimated to be at least 10 times that of the Sun, Betelgeuse has spent only a few million years in its current form, compared to the Sun's expected 10 billion-year lifespan. This is an incredibly brief existence. However, despite its short life, Betelgeuse plays a crucial role in the cosmic cycle. When a red supergiant reaches the final stages of its life, it undergoes a series of nuclear reactions that produce heavier elements, including carbon, oxygen, neon, silicon, and ultimately iron. These elements, once released into space through a supernova explosion, contribute to the formation of new stars, planets, and even life itself. Every atom of oxygen we breathe, the calcium in our bones, and the iron in our blood were once created inside ancient stars like Betelgeuse. One of the most intriguing aspects of Betelgeuse's instability is the possibility of it exploding as a supernova in the near future, at least on an astronomical timescale. While this could mean any time within the next 100,000 years, some scientists speculate that its fluctuating brightness and mass ejections suggest the explosion could happen sooner. When Betelgeuse finally goes supernova, it will release an extraordinary burst of energy, outshining the entire Milky Way for weeks or even months. From Earth, it would be visible even during the daytime, casting shadows at night. The explosion will send shock waves rippling through space, dispersing newly formed heavy elements into the interstellar medium, seeding the next generation of stars and planets. However, despite its impending fate, there is no danger to Earth. The explosion will occur far enough away that its radiation will not harm our planet, though it will be a breathtaking celestial event. The study of Betelgeuse is not only significant for understanding the life cycle of massive stars, but also for improving our ability to predict supernovae in general. Since no human has ever directly observed a supernova in our galaxy with modern scientific instruments, Betelgeuse provides an invaluable opportunity to study a star on the brink of this dramatic event. Astronomers continue to monitor its pulsations, surface activity, and expelled material to gather as much information as possible before it reaches its inevitable end. Advances in technology, including space telescopes like the James Webb Space Telescope, have allowed scientists to observe Betelgeuse in unprecedented detail, helping to refine models of stellar evolution. Beyond its scientific significance, Betelgeuse has captivated human imagination for centuries. As one of the brightest and most recognizable stars in the night sky, it has been referenced in various mythologies and cultures throughout history. It is a key feature of the Orion constellation, one of the most easily identifiable patterns in the sky, and has inspired countless legends and stories. Even in modern times, it remains a subject of fascination, frequently appearing in science fiction and popular media. The ongoing observations of Betelgeuse remind us of our deep connection to the cosmos. Every atom in our bodies was once part of a star like Betelgeuse, and its fate offers a glimpse into the processes that shaped our own existence. As we continue to study this extraordinary star, we not only unravel the mysteries of stellar evolution, but also gain a greater appreciation for our place in the universe. The vastness of space, filled with countless stars at various stages of their lives, serves as a humbling reminder that we are part of something much greater, a cosmos filled with wonders waiting to be discovered.